Okay, now we'll go through the revision test, and first question we have is log 1,000. So 1,000 we have 10 cubed, and log and 10 are inverse functions, so they wipe each other off, leaving the answer 3. 0.00001, that's the same as 1 times 10 to the minus 5. Once again, the log and the 10 are inverse functions, leaving the answer minus 5. Log of this here is we need to actually reduce the 10 down to 110. Now to do that, when you divide, you subtract the powers, so it's 10 to the 2m take n. Once again, log and 10 are inverse functions, so you're left with 2m take n. Over here, we need to, the way this should be read is that there's a left bracket and a right bracket. We're doing the log of the whole thing. Now we want to combine that into 10 to the something, so that we can then cross off the log and 10. So 1,000 we're going to change to 10 cubed. And now we've got 10 to the 2x take 4, 10 cubed. When you multiply the bases, you add the powers. So minus 4 plus 3 is minus 1, and we've still got the 2x. And now the log and the 10 wipe off, and so we're left with 2x take 1. Using logs to solve this, you do log of the left equals log of the right, because the log will bring the power down the front. So this 4x comes down the front. That's one of the log laws. And so now we just divide by 4 log 2 to get our x. Over here we could take log of the left equals log of the right, but we can simplify before we do that by dividing by 50. You divide both sides by 50, so that's 10 on the right hand side. Now I take log of the left equals log of the right. This thing goes out the front, so it's 2n take 6. I keep it in brackets. And then I want to divide the log 3 on the other side, and so now I'm down to 2n take 6. Now I have to get rid of the 6, so I add 6, and then I get rid of the 2 by dividing by 2. When I divide 2, I need to divide both terms by 2. So here's 2 on the bottom here, so I've divided that by 2, and when I divide 6 by 2, I get 3. So that's dividing the whole side by 2. 3, when you add logs, you multiply the corresponding elements, so that's log 100, which you can convert to 10 squared, and then the log and the 10 cancel, so you get 2. This one over here, we'll combine that one first. When you take logs, you divide the elements, and so that's log 4. When half log 144, that log law, that goes up to the top. And so anything to the half is the square root, so that's 12 is 144. And now a log plus a log, you multiply the elements to get 48 using one of those log laws. 4, we're given a decay function here. What's the initial weight? That's the starting point. That's going to be 2,000. It's when t is 0. Then it says find the half-life. The half-life is the time for half of it to decay. So it was at 2,000, and we want to see the time it gets to 1,000. Now when you divide by 2,000, you have a half. So a half equals that. And now we could do logs, but because we can express this as a base 2, we can make it 2 to the minus 1. We just have to equate indices. If the bases are the same, then the indices have to be the same. So minus 1 equals minus t on 60. So multiply by 60 and get the minus a the other side. It's equal to 60 years for the time to half. How long will it take to decay down to 10? Instead of 1,000, we now put 10. And we do the same thing. Divide by 2,000, so 1 on 200. This time we can't raise that with base 2, so we have to take logs. So we do log of the left equals log of the right, which is this line here. And now we have to get t by itself. So we're going to multiply by this denominator, 60 log 2. That, sorry, I'll go back again. That is separate from there. That's t minus t60 times log 2. So to get the log 2 over, we divide it, and then to get the 60 over, we times it. So times 60, divide log 2, and put all that into calculator, you get 458 years. After 400 years, how much will there remain? So we put 400 in for t. And on the calculator, so you're left with 19.7 grams. Question 5, write the following without logs. So we want to do 10 to the left equals 10 to the right. First of all, we'll just condense this into one log. So this is log m minus log k to the 4, because that can go up to the top. And we can combine these two, because when you take logs you divide the elements, so that's that one. Now we can do 10 to the left equals 10 to the right, which actually will just get rid of the log, and so you have p equals m on k4. This one here, we want to combine these two, so 2 goes up to the top, log r squared, and now when you add logs you multiply the elements, so we're now r squared f. And now since we got log d equals log r squared f, we can drop the logs. What you're really doing is 10 to the left equals 10 to the right, and the 10 and log cancel. So d equals r squared f. This one here is a graph with log k against log w. So we can write down y equals mx plus c. Now the y is log k, the x is log w, this is your slope, which is minus 5/7, and this is your c value, the y-intercept. Now we've got to solve for k, so we have to get rid of the log. So we're going to do 10 to the left equals 10 to the right. Before I do that, I've just thrown that up to the top there. Then 10 to the left is 10 log k, they wipe out giving k. And this is 10 to the log of the whole thing, it's 10 to the whole thing. 10 to that whole power. Now when you raise 10 to a power and the power has a plus, that's equivalent to 10 to the first term times 10 to the second term, because indice rules means when you multiply bases you add the powers, so that's the rule in reverse. Now the 10 and the log wipe off, giving us w minus 5/7. 10 to the 5 is 100,000, so there's our final answer for k. And the last one is mice, population of mice. Calculate the rate of growth over the 3 months. Well, from 12,000 to 70,000 there's a 58,000 increase. So the percentage increase is 58,000 divided by the original 12,000. Now that gives 4.83, but that was over the 3-month period for that increase there. So it's 4.83 for 3 months. If you divide by 3, it's equivalent to 1.61 for 1 month. Now multiplying by 1.61 is the same as a 61% increase. So it's a 61% increase per month is the rate of growth. Now in part B they say, well, what if the rate was 80%, and we'll work with 80% just in case someone got part A wrong, then it doesn't make all the subsequent answers wrong. So 80%, that means we can write it as 1.80 as R value rather than 1.61. So the final population is the initial population, 12,000, times by the rate of increase raised to the number of months. Now in this question it's 12 months, so you do 12, and so you get 13 million mice. After 18 months we do the same thing, except we put 18 there, and so you get 470 million. How long will it take to double? Well, it starts at 12,000, and we want to actually get up to 24,000 double. If you divide both sides by 12,000, you'll have 2 equals 1.8 to the n. To solve that we need to take logs of the left, logs of the right, so the n comes down the front. So log 2 equals, n comes down the front, log 1.8. And then we divide by that log 1.8, and so we've got n, which is, so it'll take 1.18 months to double. How long will it take to reach the 1 million mark? So this is the final 1 million for the final population. We do the same thing, divide by 12,000 to get 83. Take logs of both sides and divide by log 1.8. So it's 7.5 months. Now, of course, there's assumptions in this. That's assuming that the rate is always 80%. This isn't always going to be the case because we have seasonal changes, plagues, many things that would change the rate from not only year to year but month to month. And that's it. Thank you.